Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 16, 2025, about 2 days ago. This paper shows that most modern smartphones can generate a zero-knowledge proof in under 5 seconds, confirming reliable client-side proving without remote servers. The paper is titled FibRace, a large-scale benchmark of client-side proving on mobile devices, and as we'll see later, the results are really impressive. In a 19-day game using Cairo M, 6047 players produced 195, 488 on-device proofs, with stability tied to at least 3 GB of RAM and smooth Onchain verification by Hyli. Alright, the introduction covered scale and viability. Table 1 lists the 4 datasets collected during the campaign, which together captured both successful proofs and failure modes. The minted items table holds 1 row per verified proof, about 2.2 million entries. The players and devices tables track user profiles and hardware metadata, including 420 unique models. The crash logs record unsuccessful attempts, so reliability patterns can be analyzed. So the previous table summarized the datasets. Table 2 sets the benchmarking assumptions that define success for on-device proving. The minimum usable memory is at least 3 GB of RAM, which matters because devices below that limit tended to fail. The acceptable crash rate is under 1%, so stability remains visible to users. The target proof duration is no more than 5 seconds, guiding both user experience and how highly sized on-chain verification. Okay, the previous table set the benchmarking assumptions. Figure 2 shows the distribution of on-device proof durations, which is strongly right-skewed. Most activity sits between about 3 and 10 seconds, so many users experience smooth latency. The percentile lines summarize this spread. The 10th is about 1.6 seconds. The median is about 6.4 seconds, the 75th is about 9.4 seconds, and the 90th is about 14 seconds. Well, Figure 2 covered the duration distribution. Figure 1 maps downloads by country, showing broad participation across 99 countries, with the darkest shading in South and Southeast Asia, and notable activity in North America. The choropleth uses a yellow to red scale, where deeper red indicates more downloads. This geographic spread matters because diverse regions imply diverse devices and networks, which strengthens the benchmark's external validity. Alright, the previous map highlighted broad participation. Figure 4 shows proof volume by manufacturer, with the chart dominated by Xiaomi, Apple, and Samsung, which together account for the largest share of proofs. The next tier includes Vivo, Infinix, Tecno, Oppo, OnePlus, Realme, and Google, which together contribute substantial volume but clearly less than the top 3. A long tail of smaller brands follows, which reflects global market share more than any platform bias. So, Figure 4 highlighted who contributed proofs. Figure 3 shows how memory shaped outcomes, with 4 panels that link RAM to volume and stability. The top left and top right panels concentrate activity around 6 to 8 GB, which aligns with smooth proving. The bottom left panel shows many crashes on 3 to 4 GB devices. The bottom right panel confirms that the crash per proof ratio drops sharply past 4 GB and plateaus beyond about 6 GB. Alright, Figure 3 showed how memory shaped outcomes. Figure 5 ranks the top 50 system-on-chip platforms by proving duration and by proving frequency, so it directly links hardware to user wait times. Apple M series and A series lead both lists, with many devices finishing in under 3 seconds. High-end Qualcomm, MediaTek, Kirin, and Exynos follow closely and also deliver sub-3-second proofs. The combined message is that flagship chips across ecosystems already meet the target experience. So 2 takeaways stand out. Modern phones reliably generate zero-knowledge proofs in under 5 seconds, and stability hinges on at least 3 GB of RAM with strong system-on-chip performance. The broader implication is clear. Privacy-preserving, proof-powered mobile apps, and native on-chain verification are ready to ship. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.